Hello and welcome to section 5.8. We are talking today about square roots and using Pythagorean theorem. Okay, I am going to start here on the square root of 16. So I know that 16, if I'm looking for two numbers that multiply together, I get 4 times 4. So the square root of 16 is 4. Now, I might not always know what the square root is, or I might just be feeling lazy, which is totally okay. So if I put in the square root, I go 16 and take the square root, and I get 4. Awesome. And these are just calculators problems. Square root of 73. So I take 73, I take the square root, enter, and I get 8.544. And I want to round to nearest thousandth. So I draw my line between my after my thousands, and I determine am I rounding up or I'm rounding down. I am rounding down. So my answer is 8.544. Awesome. Okay. Let's do number 3. 125 square root, and I get 11.1803. So again, I'm going to draw my line right after my thousands. So I've got tens, hundreds, thousands. So I'm going to draw my line right here. I'm going to round down because 3 is a round down. So I have 11.180. Awesome. And I'm going to leave number 4 for you to try. 4 and 5. I'll let you try those on your own. Okay. So let's say that we know, or we did on our calculator, the square root of, and all of these are missing kind of a little bar-y on the top of the square root. You gotta have to imagine that it's there. But when you see it in Pearson's, they're going to be a little bar at the top. So we know that the square root of 25 is 5. 5 times 5 is 25. So the square root is 5. And the square root of 36 is 6. Okay. Now, without using the calculator, we're just going to estimate the answers, okay? The square root of, I'm going to start with 26. Square root of 26. I think that's going to be pretty close to 5 and further from 6. So I'm just going to make a guess, and I'd say 5.1 is my guess. These are just guesses, okay? And the square root of 35, well, that's pretty darn close to 36. So I'm going to say that it's 5.9. I'll rewrite this so you can see it. 5.1. And then square root of 30, I don't know. It's kind of closer to 25, so I'm going to say 5.4. These are guesses. Let's check and see how our guesses are. Our calculator, I'm going to say square root of 30. Oh, it's 5.47. Not too bad. Pretty good guess. And square root of 26. Oh, 5.1. Oh, I'm a really good guesser. And then let's do the square root of 35. And that puts me at 5.9. Okay, and these are just guesses, but the closer we get to an actual square root, it's going to be like 35 is right next to 36. It's going to be really close to the value for the square root of 36. Okay, now we're going to talk about Pythagorean theorem. Use the Pythagorean theorem to find the unknown side. Well, first let's talk about the Pythagorean theorem. I got a triangle. It's a right triangle, which means that this is a 90-degree or like a square corner. And I've got two sides. My sides are going to be A and B. And my last one is the long side, or my hypotenuse, is going to be C. So the Pythagorean theorem is A squared plus B squared equals C squared. So we're going to use this information to solve for one of the unknown sides. Okay. So here I've got two sides, 15 and 36. These are the legs. These are not the hypotenuse. Those are A and B. So I'm going to put those into my equation. 15 squared plus 36 squared equals my unknown side, C squared, my hypotenuse. Okay, so I'm going to put these in my calculator. 15 squared gives me 225 plus 36 squared gives me 1,296 equals c squared. Okay, so now I got to add these up. 1,296 plus 225 gives me 1521 equals c squared. Now I want to find c all by itself. So before, when we tried to solve things, we do everything to the same side. If I want to do the opposite of squared, because I know that square root undoes squared like we did above, I'm going to take the square root of both sides. So I'm going to take the square root here, and I'm going to take the square root here, and my square root and my square kind of undo each other. So I'm just left with c over here, and then I'm going to take the square root of the 1521, and I get 39 equals c. Awesome. And then I am going to put my answer in, and I'm going to make sure I have units. I'm looking at a length. I'm looking at feet, because my units provided were feet. This is my final solution. Amazing. Okay, we get to try it again. We're going to crush it. Okay. Again, I'm going to start with my formula for Pythagoras. A plus b squared equals c squared. So my unknown side over here, this is going to be c because it's my hypotenuse, my long side. And then plug in values. It doesn't matter which one you pick for a and b. Either way, you're going to get the same answer. A squared plus 15 squared equals c squared. Okay, so I'm going to put those in my calculator. 8 squared gives me 64. I'm going to try that again. 64 plus 15 squared. I just did that one before. 225 c squared. And I'm going to add those up. 64 plus 125 gives me 189 equals c squared. And then I want to get c squared by itself, so I'm going to do the opposite of squaring. I'm going to take the square root of both sides. So I get the square root, and here my squared and squared undo each other. So I'm just going to be left with c equals, and then the square root of 189. So take the square root over here, and I get 13.747 and some other stuff, and it says round to the nearest tenth. So I'm going to draw my line after the tenths, and I'm going to see, am I rounding up or am I rounding down? This is a round down, so I have 13.7, and then I got to make sure I have my units, which I said were feet. Oh, no, this is inches. Okay, that's an I. There we go. 13.7 inches. Okay, I'm going to let you all try number 10 on your own, and then I'm going to do number 12. Okay, so let's start first with our equation for Pythagoras. I'm going to erase because I can't look at this other stuff. It makes me crazy. Okay, let's do this one. I am starting with my equation. A squared plus b squared equals c squared. Awesome. Okay, now I have a side here. I have my hypotenuse, so if I'm labeling these, this is my c. This I'm going to call my a. It doesn't matter which one's a or b. Okay, and now I'm going to plug those values in. So I have a squared, that's my unknown I'm going to solve for, plus b squared, b is 5. 5 squared equals c squared, which is 13 squared. Then I'm going to solve my values. I got a squared. That's not a great A. Let's try this one more time. I can do better. A squared plus 25 equals 13 squared. 13 squared gives me 1 169, and I'm going to solve for x all by itself, or a on this one. So I'm going to isolate a, so I'm going to subtract 25 from both sides. My 25 over here cancels, so I'm left with a squared equals 169 minus 25, which is 144. I don't like that, that's right on the line. Equals 144. There we go. And now I want to get a all by itself, so I'm going to take the square root of both sides, because square undoes squared. Over here, this guy cancels, and I am left with a equals the square root of 144. 144 square rooted is 12. And then I got to make sure I have my units, which is meters. Meters. I don't know what I just did. How did that disappear? There we go. 12 meters. Awesome. Okay. Do we feel goodish about that? I hope so. I feel good. I feel great. And now we go, how high is the airplane above the ground? Okay. I took these pictures from the book, obviously, because I'm not capable. You guys have seen my pictures. So here we go. I have another Pythagoras problem. I'm going to start, of course, with my Pythagoras theorem, which is a squared plus b squared equals c squared. I'm going to blow this up so I have more room. A squared plus b squared equals c squared. Okay, let's label my sides. So first I have my long side, and it's on my 1,000. So I'm going to put that as c. And then I've got my other sides. Again, it doesn't matter which is which. I'll make this side a and this side b. So I'm solving for a. That's my height that I'm trying to solve for. So a, I don't know. A squared plus b squared, 800 squared, equals c squared, 800, nope. C squared is my hypotenuse. It's 1,000 squared. Okay, now I'm going to put these numbers in my calculator because these are very big numbers. A squared plus 800 squared gives me, well, this number is going to be really big. Okay, I'm just copying that, and then equals, oh no, I'm running out of room. Okay, I gotta do something here because I'm running out of room. What am I going to do? Let's write it down below. A squared plus 64,000 equals 1,000 squared. Get 1 million. Okay. Now I want to get A all by itself. So I am going to put a Post-it on here so I've got more room. There we go. And then I'm going to finish solving this. Okay, I'm going to subtract 640,000 from both sides so I can get A all by itself. These are really big numbers. We're not going to let us throw it. Sometimes when the numbers get really big, it just messes with us. But we're not. We got this. These cancel. And over here I got 1 million minus 640,000. So I get A squared equals 360,000. Now I want to solve for A all by itself. I'm going to take the square root to undo the squared. And those cancel. So I get A is equal to the square root of 360,000. I'm going to do that in my calculator, obviously. And I get 600. And then I have to ask myself, what are my units? And my units are meters for this one. 800 meters is my height. I'm going to just double check. I'm going to go back to the problem, and it says, how high is the airplane off the ground? Then yes, I did solve it correctly. I just want to double check I'm answering it because it is a word problem. Okay, let's do number 14. Gotta erase some of this so I don't go crazy. Okay. You know what? I'm going to let you all try and solve number 14 on your own, and let's do the bonus challenge question together. Let you have some to work on your own. Okay. A 10-foot ladder leans against the wall. The base of the ladder is 4 feet from the wall. How high does the ladder reach? Okay, I am going to put in the post-it note so I've got some room to write. Okay, lots of room. First thing I'm going to do, because it's a word problem and it's unfamiliar to me, I'm going to draw a picture. So I have a ladder that's leaning against the wall. And then I've got a ladder leaning against it. Very, very talented. And then it's right here. So if it's leaning against a wall and the ground form a right angle, unless it's the Leaning Tower of Pisa, but we're not talking about that. We're talking about a regular building here. Okay, and then let's label what we do have. The ladder is 10 feet, 10-foot ladder. So 10 feet. And then the base of the ladder is 4 feet from the wall. So I'm going to put 4 feet down here. And then what am I trying to solve for? It says, so how high does it reach? So this is I'm solving for x. That's what I'm trying to solve for, okay? I'm going to use Pythagoras. A squared plus b squared equals c squared. Okay, which is which on here? So my hypotenuse, my long side, that's going to be c. And then a and b don't matter. I'll make my base a, and I'll make my height b. It doesn't matter. So now I'm going to plug in values. I've got c is 10. B is x, that's what we're solving for, the height. You could leave it as b, that's okay too. And then 4 squared is a, okay? Now I've got numbers to plug in. 4 squared, 4 times 4 is 16. I don't need a calculator for that one. My brain's on fire. X squared equals 10 times 10 is 100. Now I'm going to solve for x all by itself. So I'm going to subtract 16 from both sides. 16's cancel, and I'm left with x squared equals 100 minus 16, which is 84. And now I've got to take the square roots of both sides. Square root undoes squared. And so then I get x is equal to, and I got to put in my calculator, what is the square root of 84? I definitely don't know that. 9.165. 1, etc. And then I ask myself, I need to round to the nearest tenth, so I'm going to draw my line right after tenths. And then I'm rounding up or down. The number after the tenths is my 6, and that tells me I'm going to be rounding up. So it's 9.2, and then I have to remember my units because it's a word problem, and I'm measuring in feet. 9.2 feet is my final answer. Awesome. Stay tuned. I'll also post one for 5.9 and look forward to seeing you in class.